So we're trying to determine what quadrant 14 pi over 5 is. Now, I would have a hard time figuring that out unless I changed 14 pi over 5, which is currently in radians, and I am going to change that to degrees, so that way it makes it a little bit easier for me to figure out. So I know that if I have radians, I can convert that angle to degrees if I multiply by 180 over pi. All right, so if I do that, remember that these pi's are going to cross out, and then I simply can multiply these two numbers, and then I'm going to divide that number by 5. Okay, well, that is 2520, so 2,520. We divide that by 5, and that's 504 degrees. Okay, so I know that that's over a full circle around that unit circle. So I'm going to take that 504 degrees. It's just a matter of how much around that full circle. So I'm going to just subtract 360 from that. And I'm going to get 144 degrees. So if we look at the unit circle, we should know that from here to here is 90. And then I want to go to 144, which is going to be in here somewhere. So we can see that this is going to be 144 degrees, and I can see that I'm in quadrant 2. So the answer is quadrant 2. Similar to number 1, number 2 is also asking for the quadrant. And again, we have 5 radians. So remember, the rule is to multiply by 180 over pi. Now this is 5 radians. It's not 5 pi radians. So we simply just take the 5 and we apply the rule, which is multiply by 180 over pi. Now when you put this in your calculator, you're just going to hit the pi button. So you're going to do 5 times alpha y equals, and then in the numerator put 180, and then in the denominator just simply put pi. Okay, so when you do that, you're going to end up with 286, and it's a decimal, 0.4789, blah, blah, blah. Okay, and I know that, let's just look at 286. So this is 90, 180, 270. So 286 puts me right here in the 4th quadrant. So we have a central angle that they give us, and it intercepts an arc with a length of 8 pi, and it asks us to find the radius. So I know that that is S equals R theta. Okay, so let's see what they gave us. Well, they gave us that the central angle is 2 pi over 3. So that means that theta is 2 pi over 3. And they also gave us that it intercepts an arc with a length of 8 pi. So that is our S. And they want us to find our R. So I'm going to put that there. All right, so we need to get the R by itself, right? So simply what we can do is just multiply each side by the reciprocal. So 3 over 2 pi here, which will cancel those guys out. And I'm going to try to squeeze this in over here. 3 over 2 pi there, which is going to cancel the pi's. And then we're just going to do 3 times 8, which is 24. And we're going to divide that value by 2. So then our answer will be 12. And we want to find the answer in inches, so it's 12 inches. Okay, so I drew a large circular pizza, and it's divided into 8 equal slices. Now the diameter is 20. So remember, if the diameter is 20, that means the radius has to be half of that. And then it says to determine to the nearest tenth of an inch the measure of the outer edge of one slice of pizza. Well, the outer edge would be this little segment right here, right? This little curvy piece. So again, I'm going to do just like And the last question, I'm going to do S equals R theta. All right, so S equals R theta. And they want us to determine that outer edge, which means to find the length of the arc, which is S. And we know that the radius is 10, and we don't know what that central angle is. However, and let's just do this in a different color so you can see it a little bit better. Okay, so there's my central angle. I can pick any one of those angles, right? Because if we cut the pizza right, all of those central angles should be equal. So there's 8 central angles here. Okay, so 1, 2, 3, 4, 5, 6, 7, 8 of them. So there's 8 angles there. And we know that a full circle is 360 degrees. So if I do 360 degrees and cut that into 8 equal pieces, then each of those angles is going to be 45 degrees. So there's my central angle. But remember, when I am doing this formula, this angle here always has to be in radians, and 45 is in degrees. So we're just going to take that 45, and we're going to multiply it by pi over 180, because that's how we change a degree measure to a radian measure. And when we do that, you can leave it like that, or you can simplify it to pi over 4. That's up to you. So you could leave it as 45 pi over 180, or you can make it pi over 4. Okay, so that's your call. All right, then from there, we just throw that into our calculator, and just like the last question, we are going to just please make sure that when you're doing this, you're doing 10 times alpha y equals, put pi in the numerator, 4 in the denominator. Okay, and we're going to get a decimal value, and that's going to give us 7.8539, and it says to the nearest tenth, so that means that the length of the arc is going to be 7.9 inches. All right, so we have a circle that's centered at the origin. So let's draw ourselves a picture here. Okay, so we have a circle whose center is the origin. Oof, that's a really bad circle. Sorry about that. And has a radius of 12, and the terminal side is in quadrant 3. So let's go like this. Here's my terminal side, and it intersects, that terminal side, it says, at M, and I know that the radius is 12. So that's 12. Okay, so we good so far. Now, it says that the y-coordinate of point M is 6. Now, then what that means, if the y-coordinate is 6, that means this value right here will be 6. Because if I want to find the coordinates of this point, this represents how much to the left I'm going. So start at the origin, and I move to the left however much, which I don't know. And then this 6 here represents how far down in this case I'm going. So then, again, a point, we go over a certain amount, then we go down a certain amount. And they told us that amount here was 6. Okay, it says it right here. The y-coordinate is 6. So that's how I'm getting that. So now if you look at this, what you have is a right triangle, right? And I can find this missing x value right there by doing the Pythagorean theorem. So I'm going to do x squared plus 6 squared equals 12 squared. So I have x squared plus 36 equals 144. Then I'm going to subtract over the 36. I'm going to get x squared equals 108. So x is equal to the square root of 108. I'm going to break that down. So 108 breaks down to 36 times 3. So then I know the x value is 6 radical 3. Okay? All right, so let me just throw that in there up at the top. I'll put that in red. So my x value here is 6 radical 3. Okay, now let's read what it says. It says, what is the value of tangent? Okay, so I know that tangent is the opposite over the adjacent, right? Okay, so if I look at my triangle here, here's the angle that I'm going to be starting with. Okay, the opposite side goes directly across. There's my opposite side, that's 6. And my adjacent is the one that's right next to it, but not the hypotenuse, so that would be this one. So I'm going to do this again, opposite over adjacent. Okay, so that's going to leave me with 6 over 6 radical 3. Now, I can't have a radical in the denominator of a fraction, so we rationalize that. So what we do is we multiply the numerator and the denominator by that radical. And what that ends up giving me in the numerator is 6 radical 3. And then in the denominator, I have 6 times 3, because remember, radical 3 times radical 3 is just 3. Okay? And then that gives me 6 radical 3 over 18. And lastly, I can reduce that, 6 over 18, and I get radical 3 over 3. Okay, now the very last thing that I really do need to check is I want to make sure that this value, radical 3 over 3, is positive or negative. Now, if you remember, all students take calculus, right? All students take calculus. Well, we're in the third quadrant, and tangent is positive in the third quadrant. So then I know my value here is positive. There's your answer. So the terminal side of angle x in standard position passes through the point -4, 6. All right. So -4, 6 puts us in the second quadrant. So I'm going to draw myself a triangle here. And I am moving to the left 4, but I know the length of the side of that triangle would be 4. And then it goes up 6. And we've got a right triangle. So again, I'm moving to the left 4, but it's still a distance of 4. That's why this is positive. And then we go up 6. And this is the point right here, -4, 6. Okay. It says, what is the numerical value of cosecant? I'm sorry, of secant. Okay, so well, let's think about what secant is. Secant of x is equal to 1 over cosine of x, right? And remember that cosine is the adjacent over the hypotenuse. So let's look at my angle here. And here would be my adjacent, and this would be my hypotenuse, which I don't know, but I'm going to find that out. So I'm going to do the Pythagorean theorem. So 4 squared plus 6 squared equals c squared. So that's 16 plus 36 equals c squared. So that's 52 equals c squared. So c equals the square root of 52. Now I'm going to break that down, and that breaks down to 4 and 13. So c is 2 radical 13. Okay. So now, let me reiterate again. So we know that secant and cosine are reciprocal trig functions. So I'm going to handle it in this way. If we know, and I said it a little bit earlier, that cosine is equal to the adjacent, right, over the hypotenuse, then wouldn't it be the case that secant would have to be the reciprocal of that, which would be the hypotenuse over the adjacent, right? Okay, so then in that case, let's look at the hypotenuse. And my hypotenuse is right here. It's 2 radical 13 over the adjacent. So again, hypotenuse, adjacent. So that would be 4, right? Okay, and I can simplify that. 2 radical 13 over 2. Now, let us not forget, though, that we have to do all students take calculus. So we want to look at this and we want to figure out whether we're positive or negative. So all students take calculus, and I am in the S quadrant, which means sign is positive here. But I don't have sign, I have secant. So since I don't have sign and I don't have its reciprocal trig function, which is cosecant, then this value needs to be negative. They give you that the tangent is negative radical 5 over 7, and the cosine is less than 0, and then they want you to find a lot of things. So they want you to find the sine, the cosine, and the cotangent. So listen, I'm going to figure out what quadrant I'm in, and I'm going to draw myself a right triangle, and we're just going to go from there. So I notice right here that my tangent is negative, and I notice right here that my cosine is also negative. So I'm just going to look at this, and I'm going to say, where is tangent and cosine negative? And that would be in the second quadrant, because the only thing that's positive in the second quadrant would be sine, or its reciprocal trig function, which is cosecant. All right, so now the next thing they give me is they give me that the tangent is radical 5 over 7, and it's negative. Radical 5 over 7, so that's opposite over adjacent, right? Because tangent's opposite over adjacent. So opposite, adjacent. So let me put those numbers in there. So opposite would be a radical 5, and the adjacent would be 7. Okay. All right, so I need to do Pythagorean theorem. So I'm going to go radical 5, square that value, plus 7, square that value, and let me find the hypotenuse. Okay. All right, so I have 5 plus 49 equals c squared. So c is equal, c squared is equal to 54, which means c is equal to the square root of 54. All right, that breaks down to 9 and 6. So c is equal to 3 radical 6. So there's your hypotenuse. All right, so let's look at the first thing that they want. So the first thing they want is sine. Now remember that the sine is the opposite over the hypotenuse. So sine is opposite, which is the 5, over the hypotenuse, which is 3 radical 6. Now I'm going to tackle this right now. Remember that we have to do all students take calculus. And I'm in the second quadrant, and I know sine is positive, so I can leave my value as is. All right, but let me go back and deal with the other fact that we can't have a radical in the denominator. So I'm going to multiply the numerator and the denominator by that radical. So then I know that the sine of theta is equal to radical 30, and that would be over 3 times 6, which is 18. And again, it's positive because sine is positive in the second quadrant. All right, so that's for sine. Let's go to cosine. Okay, now I know cosine, because we're in the second quadrant, is actually going to be negative. So I'm going to just put a negative there. Oops, let me make that a little bit bigger. Okay, now cosine is adjacent. So adjacent, which is 7, over the hypotenuse, which is 3 radical 6. So 7 over 3 radical 6. So I have the same issue here. I can't have that radical in the denominator. So let me multiply the top and the bottom by that radical 6. And then the cosine of theta will be equal negative 7 radical 6 over 3 times 6, which is 18. Okay, last one, cotangent. Okay, now cotangent's reciprocal trig function is tangent. So if tangent is opposite over adjacent, then cotangent is adjacent over opposite. Okay, so adjacent over opposite. All right, now I'm also in the second quadrant and I know that cotangent is negative, so I'm going to have a negative value and I'm going to do the adjacent. So let's go back here. Adjacent is 7 over the opposite, which is radical 5. So I've got 7 over radical 5. Can't have that radical, so let's multiply the numerator and the denominator by that. And let me just squeeze this in down here. So cotan theta equals negative 7 radical 5 over 5. We know that the tangent, is negative, right? So there the tangent is negative, and here the sign is positive. So the quadrant that contains an angle that would have a tangent that's negative and a sign that's positive will be in the second quadrant. Because if we do all students take calculus, in the second quadrant, sine is positive and tangent is negative. Okay, so they say that the tangent is negative 2 over 7. So I know that angle, that angle A will be right here. And then I know that I'm looking at tangent, which is the opposite over the adjacent. So opposite is going to be 2, and the adjacent is going to be 7. So 2 here and 7 here. Okay, so then it's also asking us to determine cosine and cosecant. So that's more than one value. I'm going to do the Pythagorean theorem so I can find my hypotenuse. So 2 squared plus 7 squared equals c squared. 4 plus 49 equals c squared. So c squared is 53. And c would be the square root of 53. And there's not a perfect square in 53, so I'll just leave that as the square root of 53. Okay, so first one that they want me to find is the cosine. And I know that cosine is adjacent over the hypotenuse. So if I go back up to my triangle, my adjacent will be 7, and my hypotenuse is c, which we know is radical 53. So again, my adjacent is 7, and my hypotenuse is radical 53. So we have two things here. First of all, let's go back and look at the fact that I have cosine, and I'm in the second quadrant. And we know that sine is the only thing that's positive in the second quadrant, as well as its reciprocal trig function, which would be cosecant. Okay, none of which cosine is, so this is going to become a negative 7 over radical 53. And the other issue is I can't have the radical in the denominator, so I'm going to multiply the numerator and the denominator by that radical. So then the cosine of A would equal negative 7 radical 53 over 53. Okay, next one, let's look at cosecant. Now cosecant is the reciprocal trig function for sine. So if sine is the opposite over the hypotenuse, then that would mean that the cosecant is going to be the reciprocal of that. So that would be the hypotenuse over the opposite. Okay, so let's go to angle A. The hypotenuse is c, which is radical 53, over the opposite, which is 2. Okay, so let me write that down. So that's going to be radical 53 over the opposite, which is 2. Now, let's also take into account that we are dealing with, here we go, second quadrant sine is positive, but remember, sine's reciprocal trig function is cosecant. So that means this value is also positive. So we can just leave this as a positive radical 53 over 2. And there's your answer. Part A says to find the exact value of tangent. But it does say that I have to use the identity sine squared theta plus cosine squared theta equals 1, which is one of the Pythagorean identities. And they do give me that the sine is negative 5 over 11. So I'm going to put that in and I'm just going to go from there. So I know that this is negative 5 over 11. I'm going to have to square that. Plus, and they don't give me anything about a cosine. So I'm just going to leave that as cosine squared theta equals 1. Okay, so let me square that, and I'm going to get positive 25 over 121 plus cosine squared theta equals 1. And then I'm going to subtract that 25 over 121. Okay, and you can use your calculator for that. I'm going to leave everything as a fraction. So I'm going to get the cosine squared theta, and that's going to be equal to 96 over 121. Okay, so now I want to get the cosine by itself, and it's squared right now, so I'm going to square root both sides. So I have cosine theta equals the square root of 96, and I know the square root of 121 is 11. So I am just going to break that down. Now, I'm going to go one step further, or actually, you know what? I could leave it like that for now. Let's break it down. All right, so the square root of 96 is the square root of 16 times the square root of 6. So then I know that the cosine of theta is equal to 4 radical 6 over 11. Okay, so they're asking me to find tangent. So I'm just going to put the remainder of my work, and I'm just going to go like this, sorry, just so we don't get it confused, over here on the right. Now, I know that tangent is the sine, right, over cosine, y over x. So I know the sine value. My sine value is negative 5 over 11. And I know my cosine value, I just found that. That's 4 radical 6 over 11. Okay, so what I can do is I've got a fraction within a fraction there. So what I'm going to do is I'm going to multiply the denominator by the reciprocal of itself, which will cancel all of that out. But I can't just do that. I would have to then multiply the numerator by the same thing. So 11 over 4 radical 6. All right, so then by doing that, I'm going to get my tan theta, and all I'm going to do is I'm going to multiply across. But I do actually see that I have 11s here that can cancel out. So you can do that as well, which actually I am going to do. Okay, so this 11 and this 11 will cancel out, and then that's just going to leave me with negative 5 over 4 radical 6. Okay, so negative 5 over 4 radical 6. And just like always, we can't have a radical in the denominator. So I'm going to multiply the numerator and the denominator by that radical 6. So then I have tan theta equals negative 5 radical 6. And then also remember, radical 6 times radical 6 is just 6. So that's 4 times 6. which is 24. And there's your tan theta. Now in part A, they asked for the exact value. So remember that the exact value is always a fraction. So this is our exact value. If you look at part B, and I'm going to squeeze that in here at the bottom, I'm sorry if it's a little messy, it says to find the value of tan theta rounded to the nearest hundredth. So down here at the bottom, I would have tan theta equals, and then I would just plug that into my calculator, and I get negative 0.51031, and it says to the nearest hundredth, so that's going to be negative 0.51. So then I'll box this one off so you can see the difference. Okay, so that's my answer to part B. Okay, so let's just remember that x we associate with the cosine value, right? And y we associate with sine. Okay. Now, they did give us an angle of 225 degrees, so that's this whole angle right here. What I'd like to find, though, is the reference angle. Remember, the reference angle is always between the terminal side, which would be right here, and the x-axis, which would be right here. So I want to find that reference angle so that I can determine these coordinates here. And I'll show you if you're still not following what I'm saying. So remember, the reference angle in the third quadrant, we're going to take the angle, 225, okay, and we're going to subtract 180 degrees from that, which would be 45 degrees. So that is equal to our reference angle. So what I mean by that is this. So they want us to find x comma y, right? They want those coordinates. So really what this is asking for then is the cosine of 225, comma, the sine of 225. Because remember, x is associated with cosine and y is associated with sine. Now, off the top of my head, I don't know what the cosine of 225 is, nor do I know the sine of 225. And that's why I was looking for its reference angle. So something that, remember our 30, 45, 60 chart, something that I can use to figure out what the sine or the cosine is a lot easier. So that's how I came up with 45. So in here, I'm going to put the cosine of 45, and here I'm going to put the sine of 45. Now, I'm not done yet, but because let's not forget that when we do this, we have to take into account what quadrant we're in. So remember, all students take calculus. Well, I'm right here in the third quadrant. However, what I have is cosine and sine, but tangent's the only thing that's positive in the third quadrant. So what I want to make sure that I do is I want to negate this value here, and I want to negate this value then, because cosine and sine are both negative in the third quadrant. So then I look it up on my 30, 45, 60 chart, and I know that the cosine of 45 is radical 2 over 2. But again, it's negative because we're in the third quadrant, comma, and then I look up the sine of 45 also in that 30, 45, 60 chart. And that also is radical 2 over 2. But again, I'm in the third quadrant, so I want to make sure that I negate that value. So determine the coordinates of x comma y. These are the coordinates then of x comma y. So let's take a look at this, and they're giving you a point. And notice that the x value is positive and the y value is negative. So the first thing I probably like to do is determine what quadrant that puts me in. And if the x value is positive and the y value is negative, that's going to put me here in the fourth quadrant. Okay? All right, now it says the terminal side of angle theta passes through that point. So that means that angle goes all the way around to right there. Okay? And there's my reference angle. Determine the measure of angle theta. All right, so I know that this x value we associate with the cosine. So the cosine of some angle is radical 3 over 2, right? And then over here, same thing. So I associate that, though, with sine, and I know that the sine of some angle is negative 1/2. So I guess the big question is what is this angle and this angle? So look it up in the chart. So if you go to the chart, the 30, 45, 60 chart, and find radical 3 over 2, follow it over to the cosine, and what angle is that associated with? And you can do the same thing here. The negative is, I'll talk about that in a second, but that negative just determines what quadrant we're in, remember. Okay, so if you look that up, you'll see that that angle is 30 degrees. Okay, so that means, and let me do this in a different color so you can see it, that this angle right here is 30 degrees. Okay? All right, now, so this angle here is 30 degrees, but what they want us to do is determine the measure of this entire angle right here. So I know the rule is 360 minus that angle. So that would be 330, whoops, 330, there we go, degrees. Okay, so that's my answer. Now, just quickly, I know that I said I was going to talk about this. Remember, the reason why this is positive and this 1/2 is negative, because all students take calculus. So the only thing that's positive in that fourth quadrant is cosine, as well as its reciprocal trig function, which is secant. So since sine is not either of those, that's why that value is negative. Okay? But final answer, determine the measure of angle theta, is 330 degrees.